Hello everyone, I hope you are doing fine and welcome back to our class of soil mechanics. In this video, we will try to start a new chapter of our program, the chapter number 6, which is about soil compaction. Okay, this chapter is very important in soil mechanics, in engineering. Okay, so please try to learn something. Soil compaction. This chapter is a little bit longer than the others, so it will take us maybe more time to complete it, but you will learn a lot of things in this chapter. Okay, so these are the point we will try to investigate, try to explain in detail each point. Okay, up to 14 sections of this chapter, but in this video I will just try to give introduction, okay, of this chapter and explain you briefly what is waiting for you in this chapter. Okay, so I'm going to do only these 2 points. The first one, introduction, and the second one, which is compaction in general. Okay, the general principle of compaction. If you can understand that, the whole chapter will be easy for you. Okay, that's why I want to make just one video for this, and then after that, the rest of the chapter will be much easier for you to understand. Okay, yeah. So let's start with the first point, introduction. Okay, what is compaction? What is it about? So this chapter will give you detailed discussion of soil compaction in both lab testing and field testing. Okay, how do we conduct compaction tests in the lab? How do we conduct compaction tests on the field? And how do we use the lab test in application? How do we apply it in real project, real case? Okay, so this chapter is very important because compaction is essential in construction or some structure. Actually, for almost all structure, it's important to understand compaction. What is compaction? Because here it's saying highway embankment and half dam, but actually it's more than that. Okay, we need to understand. But the embankment for road embankment or dams, or let's say in general, all structure made of soil, okay, are very influenced by the compaction of the soil. Okay, you will see this during this chapter, how compaction is important for this kind of structure. Okay, so it will help to increase the weight of loose soil, and by that it will help to enhance the strength property of the soil, enhance the bearing capacity of the soil, and reduce settlement. Okay, for the specific case of slope embankment, it will help to improve the stability of the slope of the embankment. For example, road embankment or even dam, half dam embankment, the slope, it will help to reduce the instability or to increase the stability of the slope. Okay, so it's very important for this kind of structure. So how do we do compaction? as I told you, we can do compaction in lab and the field. But even the compaction that we do in the lab is just to help us conduct good compaction on the field. Because based on the result of the lab test, we will try to put the soil in the condition to obtain a very good compaction. You will see that there are several conditions that need to be covered to achieve a very good compaction. Okay, so how do we conduct compaction on the field? There are some equipment that are used for that. We have this kind of equipment, smooth well roller, this kind of machine, for example. Okay, so it's heavy. So when it passes on the soil, it densifies the soil, because compaction is just densification of the soil. Okay, sheep foot roller, this one, as you can see, this one look like sheep foot. Okay, that's why the name is like. Another one is rubber type roller. This one, see, just plastic rubber. Okay, another one is vibratory ruler. This one is heavy and also is vibrating or vibration. So because of the vibration, the densification can reach deeper part of the ground. Maybe not much deep, but deeper, not only at the surface. Okay, so actually there are more. This kind of machine, there are a lot more, but we will just limit it to here. Just keep in mind that there are machines to make soil or embankment, your embankment, make it denser. Okay, so let's continue. So I will just keep this here. For this last one, this specific vibratory roller, it mainly used for densification of granular soil. Okay, for compaction of granular soil, like sand or gravel. Okay, for clay, this one is used mainly. Okay, this one is very specific for granular soil. Okay, another thing is another method used for compaction is this one, vibrofloat device. The technique is known as vibroflotation. Vibroflotation is a method of compaction used for granular soil to compact in a very deep part of soil. Also for granular soil deposit, but for significant depths in the underground. Okay, this machine, for example, this photo show one example of this kind of techniques. So we insert something in the ground, deep down in the ground, and vibrate. The vibration will densify the soil. This is the head of this stick. I don't know how to call it. Maybe not stick. The head is here, deep down in the ground, and it vibrate and make the soil denser. This is explanation of the technique. Okay, just insert. You see the arrow here. Maybe it's small, but just insert this device in the ground like this and densify. After bringing vibration, it will densify the soil. And you pull out your device, and after that, this part of soil will be densified. So this is how we do compaction, because compaction is just densification, okay? So this is just for your information. So this one is not used for any type of project. But those who are dealing with road and dams, this kind of thing, you need this to know this kind of equipment. Okay. Let's continue. So in this chapter, we will cover principle of soil compaction. As I said, both in lab and field condition. So to do that, we will cover several topics, and these topics are as follow: laboratory compaction method. So we will explain how to conduct compaction in the lab. So take soil sample and how to do it. What is the equipment used for compaction? We will also talk about factors. What are the factors affecting compaction in general? Okay. Another thing we will do is empirical relationship related to compaction. There are some relationship related to compaction. And also, when we compact clay, or let's say cohesive soil, as you know, clay is always complicated. So compacted clay is somehow changing. The structure and property are changing. So we need to investigate, we need to study, we need to know the structure and property of compacted clay. So we'll discuss this also in this chapter. And of course, field compaction. We have already introduced this in the introduction, previous slide. And test for quality control of field compaction. If you do compaction using a machine or all equipment used for compaction on the field, how do you know that the soil is well compacted? What are the procedure you use, or the company in charge of quality control used to control if the compaction is okay or not? So you need to know that also. Okay. And also special compaction techniques in the field. There are some very special techniques for compaction. So we will discuss these points in this chapter, okay? Next, the second section of this chapter. So we are done with the introduction. Let's go now for the second section, okay? Principle of compaction. So general principle of compaction. So as I said, compaction is just densification of soil. So compaction is the process of making soil denser, just to increase the density of soil. This is compaction. Technically, this is compaction. Okay. So it works by eliminating the air in the soil through mechanical energy. Okay. This is what you need to understand. Compaction is just densification of soil. So by eliminating the air in the soil, we make the soil denser. This is compaction. So the extent of compaction is gauged by soil's dry unit weight. So by weighting the dry soil we know how to say that, how good the compaction is. Is it well compacted or not well compacted? By checking the dry unit weight of the soil. Okay, so you may have the same soil. For a compacted soil, well compacted soil will be heavier with the same volume of soil. Okay, because it's well compacted. So if it is well compacted, the dry unit weight will be high. Okay, so that's why we use dry unit weight to judge if the soil is well compacted or not. You need to keep this also in mind. The gauge what we are using to judge if soil is well compacted or not is the dry unit weight. Please remember that. Okay, so when water is introduced during compaction, it functions as lubricant, causing soil particles to slide and settle in more tightly packed arrangement. So that's why we need the water. But you will see that the amount of water that is needed for good compaction is somehow an optimum amount. You cannot put the water anyhow also. Okay, but we need water to do good compaction. Okay, so initially when we have a moisture content and we increase the amount of water content, the moisture content, normally the dry unit weight after compaction will increase. It means that if we add water initially, if you take the soil, a dry soil and dry loose soil, and you add water and compact, it will increase the dry unit weight. But remember that we use the dry unit weight to judge if the compaction is good or not. Okay, so by increasing the moisture content, the water content, dry unit weight of compacted soil increases. Okay, this is what this figure is showing here. At the beginning, we have this is unit weight. So unit weight is gamma 1, is gamma D when water content is 0. So we are here. So then water content 0, we are here. And when we add water, we will go like this. The unit weight, the dry, please remember, this is just dry unit weight, okay? Dry unit weight. And this is water content. See, water content, dry unit weight. So by adding water, by increasing the water content, the unit weight, the dry unit weight increases. Okay, like that. This is what this figure is telling us. Let's keep the same figure here. So when the water content is 0, means it's dry. Okay, if there is no water, it means the sample or the soil is dry. Okay, in that case, the unit weight will be same as the dry unit weight. That is normal. I think there is nothing to explain here. It is very simple. You understand already. So in that case, we can easily write something like this. We can easily write this relationship. We can say gamma is equal to gamma dry, D is dry. When water content W or omega is 0, which is equal again to gamma 1. Everything is here. Okay, gamma 1. Gamma equal gamma 1 equal gamma dry, gamma D, when the water content is 0. Okay, that is not complicated. Next, when the moisture content is gradually increasing, and we use the same compaction effort, the weight of soil in a unit volume gradually increases. This is just the unit weight, okay? And this is what I have explained before. If you add water, you increase. If you are here, it dry. And if you add water and compact the soil, the water will help compact the soil to be compacted very well. And then naturally the dry unit weight increases also, like this. Okay, so for example, when we are here, as you can see, or here also, so when we are here, water content 1, omega 1 here, we will have unit weight gamma 2. Okay, so we can write this gamma in that case is equal to gamma 2. That is very simple, I think. Okay, gamma 2 here corresponding to here. So it means we have this an increment of a dry unit weight delta gamma D, which is gamma 2 minus gamma 1 here. Okay, technically this one should be here. So the dry unit weight at this moisture content is given by this formula. Dry unit weight at this point means this one is given by this formula. A delta gamma D, this portion, plus this one, gamma D, when the water content was 0. That's the meaning. What is interesting for us is this point. Once you reach this point, the water content number 2, the moisture content number 2, this position, you will have the maximum unit weight possible. Beyond this water content, omega 2, if you add more water, instead of increasing the dry unit weight, you will obtain reverse effect. The dry unit weight will decrease. This point is what I need you to understand. Okay? When you add water, at the beginning, the dry unit weight will increase. It means the compaction. If you compact, it will increase. The compaction will increase. The dry unit weight will increase. And At certain point, if the water reach a certain optimum, the dry unit weight will not increase anymore. So if you add water, it will decrease the dry unit weight. We focus on dry unit weight because, as you know, as I explained before, the dry unit weight is what we are using to gauge, to measure, to judge if the compaction is well done or not. So we need the dry unit weight. We need to know the behavior of dry unit weight. So remember that there is an optimum here. Water content. This optimum water content is what all compaction, trust me, is about. Even on the field, construction field, you will see some water tank, the cars putting water on the embankment, for example, before compaction. This amount of water is well calculated, well known. So you need to know that. If you go above this line, you will lose something. You will lose the the effectiveness of the compaction. There is a term for that, but maybe I'm just trying to avoid to say that first. Degree of compaction. Maybe you understand. Degree of compaction. Maybe I can use it without any problem. So if you don't reach the point, the optimum amount of water also, you will not have a good degree of compaction. It will not be near 100%. Okay? But of course, to obtain this point, it is very difficult. So sometimes there are some tolerance that are accepted depending on the project. Okay. But I need you to know that there is specific water content above which adding water is not effective anymore. That is the whole chapter here. That's why I'm losing time here, really. That's why I'm spending too much time on this. So this happened because when you put too much water, this water is going to fill the gaps in the soil, fill the spaces, and these spaces, they were supposed to be occupied by soil particles. So if water enter there, the soil particle cannot enter anymore. That's why if you add more water, it will not be effective. Okay. So the moisture content at which the maximum dry unit weight is achieved is commonly known as optimum moisture content. Optimum moisture content or optimum water content. Okay, remember that, and the rest of this chapter will not be difficult for you. Sorry. So there is a test in the lab test. There is a lab test for that to detect, to know what is the optimum moisture content. And this lab test, the name is Proctor compaction test, developed by Professor Proctor in 1933. And this test is widely used in laboratory for determining the maximum dry unit weight and also the optimum moisture content, because as you can see, the maximum dry unit weight is equivalent to the optimum water content here. Okay, so this test is the test that help us to know what is the optimum moisture content, or what is the maximum dry unit weight. So maybe in the next video we will even talk about this test. Okay, but this video one is just introduction. So the test procedure is described in the following section. Okay, next section, next video. Thank you very much. This is all for this one. Okay.